This is my second video in my module on writing equations of graphs. So we're getting the trig functions now up front graphed, and what we want to do is we want to write the equation of these. So very quickly again, let's go ahead and write down the simple template that we're going to be using here. But for all of these examples, I'm going to be using sine and cosine curves. So we say these are some functions a times a sine or cosine of some bx plus a c value plus a d value, where again we know that the amplitude of this graph is the absolute value of a. We say the period of this graph is equal to the normal period of sine or cosine, which is 2 pi divided b ways. We say if it's reflected, answering this question reflected, we're really asking this question here, is a less than 0, we say that the horizontal translation, this is also referred to as phase shift. So horizontal translation, this is equal to negative the c value over the b value. So basically, whatever the c value says, we're going the other way. We're going to shift the other way. So if it's positive, we'll shift left. If it's negative, we'll shift right. And then we say vertical translation. Vertical translation is a very easy one to determine, a lot easier than horizontal translation because it's equal to just the d. Okay. So knowing all of these things, our job today is going to be this. Let's go write the equation of this graph and just fill in these values. So we have a times the trig function of some b, x plus c plus d. We're going to fill all these things in just by writing down what we know about them. So how about we start with this? What do we know about this? All the things we know about it. Well, it looks like when I'm looking at this, it looks like a sine curve. Okay, so the first thing I want to do is I want to identify. Identify the function. So for instance, we know that this is a sine curve here. So I'm going to go ahead and write sine right there. The next thing I suppose we could do is identify amplitude. So identify amplitude. So when we look at this graph here, we say from the maximum height to the minimum height, this is a total distance of 6 units, and we say the amplitude is half of the distance from the max to the min. So we say its amplitude must be 3. Now the thing here is this, is it a positive or a negative 3? And to determine this, what we have to do is we have to look at this graph and say, well, was it a reflected sine curve? Now a normal sine curve usually goes up, down, up. Reflected would look like down, up, down. So since it's not been reflected, what we can say is this, then this must be a positive 3. Okay, so moving on, we say, well, what's the period of this graph? The period I notice is I could say start here at a crest and then go to another crest and say, well, what's this length right here? But it doesn't look like it's marked on the x-axis. But I do notice that I could start here, go up and down, and then back up to 0 again, and go through a full cycle in the same amount of time, and it looks like a pi period input. So here's the thing about this. We need to set, let's write this down. We're going to set the graph period equal to 2 pi over b, and this is if it's sine or cosine, we are going to do this. So we take 2 pi over b, which is the period, and we're going to set it equal to what the period equals, which in this case the period is just pi. So if we solve for b here, I'm going to show you how to do this. This is a letter b. Since we have a proportion that is 2 equal fractions, what we could do is we could solve a cross product. So we could say that the b times this pi right here has to be the same number as 2 pi times 1, which is just 2 pi. And then solving by dividing both sides by pi here, looks like we get b, and b is equal to 2. So we say b is equal to 2. So far we've gotten a is equal to 3 and positive 3. B, rubbish at b's. B is equal to 2. So we can go ahead and fill in this 2 right here. But we say set period equal to this, and then solve for b. So I'll say this, number 4 is look for vertical translation. I notice that this graph here, we're going to kind of imagine this next graph, you'll see in a minute, is vertically translated, but this right here has kind of like this imaginary center line that it keeps going 3 above and 3 below and 3 above and 3 below on. So same thing here, but that center line is at y equals 0. So we could say, well, then the d value must be 0. So far we've gotten a is 3, b is 2. This hasn't been vertically reflected, or sorry, shifted at all, so d is 0. And I notice it hasn't been shifted left or right at all, so we could say that c is also 0. So in this case, we'd really just get this function right here, where we have y equals 3 sine 2x. So basically, this is a sine curve that has an amplitude of 3 and goes through 2 complete cycles in a normal 2 pi period, or just has a pi period, okay? And so number 5, let's go ahead and write this in. We say, look for horizontal translation, and then set equal to negative c over b and solve for b and c, which at that point we'd already know b. Okay, so let's go ahead and take a look at this curve down here. We'll write down what we know. We say its amplitude. What's its amplitude? Looks like it has an amplitude. It goes, starting here at 2, I kind of imagine this horizontal center line that goes through this. It's going 3 above and 3 below and 3 above and 3 below. So this looks familiar to me. It goes up to 5 and down to negative 1. So we say its amplitude is 3, which is half this distance of 6. We say, what's its period length? Well, it starts here, goes through a full cycle, and comes back here at pi units. So we say period is equal to pi. Okay, is it reflected? No. So we say that this means that A is positive. How about vertical translation? Well, it looks like it's been shifted up, and it looks like it's shifted up 2. So we say up 2, and then we say horizontal translation. It wasn't shifted left or right at all, so we say 0. So knowing all the things that we know up here, that we had listed up here, we can say things like, well, then the A value must be 3, and it must be positive because this is a sine curve, but it's not been reflected. So we say positive 3. We say the b value. Well, to find the b value, you set this period equal to 2 pi over b. So if 2 pi over b equals pi over 1, then we could say, well, then this is the case. We get b times pi is equal to 2 times pi, where then this makes sense that b is equal to 2. So b is equal to 2. C, we had no horizontal translation. And D, this one's been horizontally translated up twice. So these are all of our values here for our equation. We'll just go ahead and fill these in. So we have y equals, it's a sine curve, so we say positive 3 sine. Bx, so we say 2x plus 0 for C plus D. So you could write this also otherwise as 2 plus, and we could put that 2 plus out front and just say 3 sine of 2x. Okay, so this would be our equation there.